Let's look at interquartile range. Here are the ages of the 56 signers of the Declaration of Independence. 40, 53, 46, blah, blah, blah. We know how to find the median age. We've seen that before. To find the median, we put the values in order and find the middle value. So here are the values. In order, these are the values. And to find the median, again, we find the middle value. If you have 5 values, it's the middle value. There are 56 signers. That's an even number. What do? Well, since there's an even number, you take the average of the middle 2 values, and that's your median. So here, in order, are the values. First 28 values in red, second 28 are in green. The middle 2 values are 44 and 45, so the median is 44.5. Okay, we say that the median is the 50th percentile because 50% of the values are less than it. Again, here are the 50% of the values that are less than the median. Similarly, if the score is at the 25th percentile, 25% of the values are less than it. How do we find the 25th percentile, also called the first quartile? Look at the scores that are less than the median and find the median of those. Okay? So again, we have seen that the median is 44.5. The red scores are the ones below the median. There are 28 of them, which is an even number, so there is no middle value. The 2 middle values are 36 and 37. Okay, I've highlighted them in blue. Their average is 36.5, so 36.5 is the 25th percentile, or first quartile. We call it the first quartile because a quarter of the scores are less than it. Similarly, if a score is at the 75th percentile, 75% of the values are less than it. How do we find the 75th percentile, also called the third quartile? Look at the scores that are greater than the median and find the median of those. Okay, we've seen the median is 44.5. The green scores are the ones above the median. There are 28 of them, which is an even number, so there is no middle value. The 2 middle values are 50 and 50. That's convenient. Their average is 50, so 50 is the 75th percentile, or third quartile. And again, it's called the third quartile. 3/4 of the scores are less than it. 3/4 of the scores are less than 50. We've seen that the first quartile is 36.5, and the third quartile is 50. The distance between the first quartile and the third quartile is the interquartile range, or IQR. It is a measure of how much variation there is in a set of data. In this case, the IQR, interquartile range, is 50 minus 36.5, third quartile minus the first quartile, which is 13.5. Okay, the standard deviation is also a measure of how much variation there is in a set of data, how spread out the values are. But it is sensitive to outliers, extreme values. So if the distribution is skewed left or right, then the interquartile range is a better measure of the spread of the data, how much variation there is in the data. Let me show you an example. Okay, here again are the ages of the signers of the Declaration of Independence. We've seen the first quartile is 36.5, third quartile is 50, so the IQR is 13.5. It turns out that the population standard deviation is sigma squared equals 10.38. You can use Excel or SPSS or even your TI-83 to calculate this. What happens to the IQR and the standard deviation if we change that last value, that oldest person, from 70 to 120? Okay, suppose instead of being 70, the oldest signer were 120. The first quartile is still 36.5. Okay, so no matter how big this is, first quartile is still 36.5. Third quartile is still 50, so the IQR is still 13.5. However, the population standard deviation goes from sigma squared equals 10.38 to 14.04. Again, having an extreme value like this causes the population standard deviation to balloon. So both the standard deviation and the IQR are measures of spread, of how much variation there is in a set of data. But when a distribution is skewed left or right, the IQR is a better measure of spread because the IQR is less influenced by those outliers, like 120 years old. If the distribution is unimodal and symmetric, the standard deviation is just fine, just dandy as a measure of spread.